So, what does an open dot mean in inequalities or on graphs? It's above or below, but not that number. So not equal to. And the closed would then be, surprise, surprise, equal to. Okay, there's a couple inequalities we should review. Now, one thing I'd ask you is that from now on, that you always say your variable first. So what I mean by that is if I was given something like this, I wouldn't, instead of reading it as 2 is less than x, we always refer to our variable. Everything's compared to the variable. So x is greater than 2. So remember, the alligator eats the bigger one, all that good stuff. So let's do a little review of terminology. So if I had that, what does that mean? X is greater or bigger is correct, but we usually say greater. But x is greater than 2. All right, next symbol. What is the difference between the top and now this guy? What does that mean? Simone? Greater than or equal to. X is greater than or equal to. Okay, so if we had now this guy, what's that going to be? Less than, x is less than, and if we had this, x is, I should always say x is. Uh-oh, I guess I'm going to have to erase. Say the x is less than, and last, x is, uh-oh, less than or equal to. Okay, so that's a review. Hopefully you liked inequalities, because domain and range, we are going to need inequalities. So far we only looked at domain and range in terms of just discrete data or tables. We're going to look at graphs today. How do we write domain and range for graphs? So let's just do a quick review. How do I plot x equals 5? Open or close dot? Closed at 5, because, yeah. Okay, next guy. How would we read this? X is less than 4. So less than is what direction? So it's an open dot because it doesn't have an equal to symbol at 4. And less than, is that going to be the left or the right? The left. Less than is the left. Right, so we're going to the left. Next guy, how would you read that? X is on the, right, when we look at the arrow, X is on the open side here of the arrow. The larger side, we'd say X is greater or equal to. And so when we have greater, it's going to the what direction? The right. Greater's to the right. So is it open or closed at -1? Closed, and then we're greater, so to the right. All the numbers that are larger than -1. Now, if it's 2 numbers are involved, you have to treat it one at a time. So basically, we cover up the inequality for 4, and we just deal with the inequality for the -5 first. Now, what you could do to start is, we know we're going to need an open dot at 5 and a closed at 4. So that's where you can start. You can put your points on, and then we can worry about our shading. We worry one at a time. So this one, x is, read x first. X is that on the larger or the smaller side of the arrow? Larger. X is greater than -5. Greater is to the right. If you forget your left and right, remember your L for left, check mark for right. That's how I got through driver's training. Okay. Next guy. Cover up that guy. X is less than's to the left of 4. So that's how we'd write in between two values. Okay, the next guy, open or close at -4? Closed. And open or closed at 6? Open. Now let's do it one at a time. So dealing with just the -4 part, X is less than -4, so to the left of -4. Now, just ignoring the -4, just looking at the 6, X is greater than 6 means to the right. So basically, it's everything but what's in between the two numbers. Now, if I wanted to write the inequalities, and it's between, how we start off is we put the X in the middle, and then our two numbers, that where it starts or finishes, are going to go on the left and the right of X. Now, the smaller number should always go on the left. So which number goes here? -6, and the 4 will go on this side. Now, we have to figure out our inequalities that go inside. For this guy, are we shaded to the left or the right of -6? To the right. So if it's to the right, X is greater than or equal to. So the X is greater. Now, the 4 is to the left, and so X is less than or equal to. Can you try these two right here? Write out the inequalities. And then when you're finished, can you please shade in the bottom two? Thank you. Okay, so here, this one, you should have X is greater than, not equal to though, and -3, and then less than or equal to 8. So your arrow's that direction. The next one, it's going to the left of -3, so that's less than. So X is less than -3, but it's to the right of 1, so X is greater than or equal to 1. The bottom, so we're dealing with -2 is open, 5 is closed, and you might have noticed a pattern. When the arrows both point to the left, it's just in between, right? Because it's going to be greater than -2, less than 5. When the arrows point to the right, what happens? They don't meet. They go opposite directions. Greater than 6, less than 0. Okay. All right, so let's apply inequalities to domain and range. So domain and range is, remember, domain is the element in the first set, or it's the x variable. So how does that translate to a graph? Well, it's the location of the x's. Can I go on to the next page? So domain and range is our location. It never tells you what it looks like, but it does tell you where the graph is located on the coordinates, on the x and y coordinates. Okay, so x, how do I figure out where our graph is on the x? We're basically going to ask, how far is it left and right? Where is it located horizontally? How far left and right? And the range value, we're looking at the vertical axis, right? So we want the locations of the y coordinates. So that's going to be how far up and down. Now you must know that domain is x, range is for y. It's alphabetical. right? X comes before Y, D comes before R. Also range, I've heard this before, looks like the G kind of emulates the Y. It's a little weak. Just know which one's which, please. You have to know that. Don't want to mix those up. That's no fun. Okay, so for discrete data, what is discrete data? Not connected. Not connected. So basically you have to draw it by lifting your pencil. So usually it involves points, but non-connected is discrete. Okay, so discrete data, we've seen discrete data before. So writing our domain and range. Now, I'm going to write the formal way and then the informal way. Okay, so we're going to focus on just using set notation. Okay, so formal way to write domain, you would have to do the following. Oh, actually, let's do it on the next question. Can you do this?
No, I can't.
Oh, that's really too bad. Sorry, you could just leave informal and formal up there. Sorry. It works better for the next question, I just realized. Okay, domain. So when it's discrete data, we're listing just where the location of the x's are. So how far left and right is our graph is really answering what x's does our coordinates hit. So what x values do the coordinates hit? We have a 2, 1, 0, -1, -2, -3. Normally we list from least to greatest. Okay, how was that so far? Does that make sense? Right? If it made a shadow on the x-axis, all our coordinates, right? If the shadow on the x-axis would always be in these numbers. Now the y values, if it had a shadow on the y-axis, where would it hit? The lowest one would be at -2. There's a point at 0 and 1, or 1 and 0, sorry. Then also at 2, 3, and 4. So -2, 0, 2, 3, 4. Okay, domain range. So that's very similar to what you've seen before. Manageable? Yes. Now what do we do when it's a line? So when it's continuous data. It's continuous. What's continuous again? You keep the pencil on the paper. You can draw it without lifting your pencil. Everything's connected. Right? Continuous connected. C-O-N. Connected. Continuous is connected. So, how do we do it? Well, if it's continuous, that means our domain and range is going to involve inequality or XER/YER. Now, that might not mean anything to you yet. Please write it down, and then we will explain what that means in a moment. So write it down for now. So as long as it's continuous, our answer is going to involve either inequality, just like what we reviewed, or it's going to involve XER or YER. So let's look at this problem here. So what are the location of our x's? Between what values does this graph go? Between -2, if it were made a shadow on the x-axis, it would land between -2, 1, right? How far left and right does our graph go? It goes as far as -2 and as far left, and as far right as 1. Okay, that's the location of the x values. So how do we write that? Well, the formal way to write domain is the following. Open set, bracket, Because we're dealing with domain, we're going to say which variable does domain deal with? X. So x with a bar. Then we write our inequality. So x is between what two values? -2 and 1. So we put x in the middle, -2 on the left, 1 on the right. And then we figure out, okay, so if we're to the right of -2, that means x is greater than or equal to -2. And if it's to the left of 1, x is less than or equal to 1, comma. Within that, because it's continuous, we're going to write XER. So what that means is inside that, it's connected. And what does the E mean? Do you remember that? Element of what? Real numbers. Remember, all real numbers are numbers on a number line. Okay, that's the very formal way to write it. How do I expect you to write it? All I expect you to write is this part. X is between -2 and 1. Why did I show you the very formal way? So if you see it on a multiple choice, you're not scared of it. All that other stuff is just hoity-toity math notation. Yeah. Pinky up type stuff. Okay. Range. What question are we asking yourself to find out where the range is? Range deals with what variable? The y. And the y-axis is vertical. So how far up and down? How far down does our graph touch? -4 all the way to 4. If it made a shadow on the y-axis, it would be between -4 and 4. And so the hoity-toity way, y with the bar, we put y in the middle. It's between -4 and 4. We put in our inequalities. So if it's above -4, x is above is greater. And if it's below 4, that translates to less than. Now notice, whenever it's between two values, do you notice how it's always pointing to the left? Whenever we have between two values. And notice how the arrows are always the same direction. Comma, y-e-r. Now, what do I need to see? Just this part. Yes, Simone. Oh, sorry. Okay, so I'm going to write that on the above. For y, if it's above the number, that's greater. That translates to greater. If it's below a number, that's less than on the y-axis. This is for the y. So here, we were above -4. So all our numbers are greater than -4. All these numbers are greater than -4. Right? And we were below 4, so all these numbers are less than 4. Oh, because it's a solid, right? It's because of this. Okay? So x was between, where is it between on the x? Between -2 and 1. Okay? So they're usually an equal to symbol in all of these unless it's an open dot. Okay? Okay, let's practice a whole bunch. So now that we got the informal lingo out of the way, we're going to just get practice and we'll write it the informal way from now on. So I just want you to have that down. So if it's just, that's on your diploma in 2 years. That's how they'll write domain and range. Okay. But it's really, all you got, and even on your answer key and your worksheet, if you look at the back, where's the portion that you need to look? You just need to look at this stuff. Right? On the back of the answer sheet. Okay. So, let's try this guy. Domain and range. So I'll just write D and R. So domain, we're going to ask our what question? How far? What direction is the x-axis? Left and right. How far left and right? How far left will this graph go? There's an arrow on it. So will it keep going forever to the left? Yes. How far right will this graph go? Forever. So if it's all numbers, how would we write all numbers? No, instead of infinity to infinity, we actually write it, x is an element of the real numbers, xer, because it's forever to the left and forever to, that's all numbers. X can be every single number. Will the graph touch 1,000? Yes. It's going to keep going, and there'll be an x value for 1,000. Because there's arrows on it, it keeps going. They only show you a small portion of the graph, but because the arrows tells you it keeps going. So y, the y value, is YER. Why is it YER? Will it go up forever? Yeah. Will it go down forever? It's going to keep going down forever. And so it's YER. Y is an element of the reals. Yep. Cool. Next page. B. Okay. So the location of domain, the location of our x values. The location of the x's. So how far? Well, careful. How far left and right? So let's start. How far left will this graph go? Will it keep going forever to the left?
Yes.
Yes. It keeps going forever to the left. How far right does the graph go? Till 0. It stops at 0. Right? The graph doesn't exist to the right of 0. So whenever we have a restriction, we're going to have an inequality. So here there's only one number that's affecting it. What number is that? 0. So we write x first. X is, now, is it, yes, to the left of 0 means less than or equal to 0. Because it's to the left of 0. That's my location of the x values. Range, the y values. So we ask ourselves what question? How far for y? Up and down. Will this graph keep going up forever? Yes. Will this graph keep going down forever? Yes. So if it keeps going up and down forever both ways, how do you write that? YER. Y is an element of the real numbers. Now you don't have to do the little highlighting method. It's just a strategy. Okay, you might be able to just look at it and see the answer. Do you want to try E?
Yes.
Or do you want to do E together and try F? Try E together and do F on your own. Okay. Domain. What question is going through your head? X, good. Domain is X. And how far left and right? How far left does our graph go? Up to -2. And how far right? It keeps going forever to the right. So we're starting at what number? Starting at -2. So we're going to write x is, because it's going to the right, right means greater than or equal to -2. -2. Okay. Now, range, what's going through your head? What should be going through? How far up and down? Y. How far up will this graph go? It keeps going up. Yeah, it will keep going up. How far down will this graph? Forever. So you would write YER. Please try F on your own. Domain. Domain. How far left will your graph go? It's going up and up and up and up forever, or I should say left and left and left and left. Is it going to keep going to the right? Yes. Should add XER. Range. Up and down. Where does it start for up and down? Kaiser. Wake up. Okay. Up and down it starts at? So y is greater than or equal to -3. It's above -3. Okay. G. So be careful. When we're saying how far left and right, we're saying, okay, where is a graph? What two numbers is the graph between on something like this? Okay. What two numbers is our graph between for domain? Remember, if it's in between two numbers, we put x in the middle, put the small number on the left and the large number on the right. So we'd say x is, if it's to the right of -5, greater than, equal to, and then less than or equal to. Notice how whenever it's between two numbers, it's always pointing to the left. Range. What two numbers is our graph between? -3 and 7. -3 and 7 are y's. So we'd write -3 y 7. Which way is everything pointing? Which way is everything pointing? What's that called? To the left, to the left. Yeah, I was like waiting for that and you guys weren't like saying it. Okay, next one. No, sorry.
So if the signs be the same for both, then
No, not for both. Just for these ones, yes, not necessarily for both of those.
well, I mean like when you're getting like something, if it's like -5 and then like that, then the next one wouldn't be the same sign.
Not necessarily. Only here would be the same. Okay, moving on. Oh, no. Okay. Try the next one, please. Try the next one. What two x values is your graph between? What two y values is your graph between? Okay, so try and write that domain for the next guy. Okay, so this guy, domain, between what two values are we located in on the x? -3 and 3. So we put -3 on the left, x in the middle, and the large number on the right. Now, looking at this, our graph is to the right of -3. So x is greater. It's on the greater side of the alligator. Greater alligator. Nice. Now, the graph between what two values? Oh, I'm not done. Sorry. It's the left of 3. So left is less than. So x is on the small side. Range is how far up and down. Now, again, in this case, it's between two numbers. So how low do we go? -6. All the way up to 3. That's the location of the y's. So I put -6 on the left, 3 on the right. And again, they're both going to be pointing to the left. It's in between two values. Y is greater than -6 and it's less than 3. No, -6. It drops. Okay. Okay, next one. What do we do with discrete data?
Everything.
No. Shh. Caleb, please stop talking, okay? What do we do with discrete data? Bruno, save that for later. We just list the numbers for discrete. Just list the numbers. So x's, what numbers of x do our points land on? -2, -1, 0, 1, 2. What numbers do our dots land on for y? Which values of y? 0, 1, and 2. 0, 1, and 2. Okay, skip example 2 and go to, oh, the bell's going to ring right away, isn't it? It's, oh yeah, I do this every time. Moving on. Yes, praise the Lord. Okay. Thursdays think that we're done at 1:50, but it's 1:05. And it's actually only 12:50 right now. Okay. A variety of corn plants grow at an average rate of 4.5 centimeters per day from the start of the 3rd week of growth to the end of the 6th week. The plant's growth can be modeled using the formula h is equal to 4.5 times a plus 25, where h is the height of the plant in centimeters and a is the age of the plant in days. Okay? It says create a graph of the corn stalk's height from the beginning of week 3 to the end of week 6. Express the domain and range. Okay. Well, what's the problem with typing that into our calculator?
You get the graph.
Pardon me? We do need to know what.
Like, wouldn't h just be the y?
Okay. There's a problem with that. And the problem with it just using our calculator, because h would be the y and a the x, but there's a restricted domain. Because when are we looking at for this graph? Time between what time? Beginning of the 3rd week to the end of the 6th week. Another problem is what? Our formula, our two variables are what? Height and days. And we have weeks right now. So let's look at our weeks. Week 1 is between what 2 days? Day 1 and day 7. Day 1 to day 7. Week 2 would be between day, no, 7's already is part of week 1. 8 to 14. Week 3 would be from 15 to 21, multiples of 7 here. Week 4 would be from 22 to 28. And week 5, 29 to, add 7 to 28, 35. And week 6, from 36 to 42. So, it says we start on which day? 15th, the beginning of week 3, and we end on day 42. So, we need to figure out what on those 2 days? The height of the plant. How can we find out the height of the plant on day 15 and day, don't we just sub in the numbers? Don't we? Yeah. We have an equation. Our height is equal to 4.5 times the day number plus 25. Does anyone want to take a guess what that, well, first, what does the 4.5 represent in the formula? How much it grows each day. It's our rate of change. Does anyone want to take a guess of what 25 represents? Danny? No. Close. No. Okay. Yeah, Ryan? You're getting there. How tall at the beginning rate? Yeah, before we even start, at day equals 0. So before we start this program, so the beginning of basically the season, that's its initial amount. The initial amount's beginning of the season. So before day 1, basically. Okay, so it's just a youngling. Okay, but we want to find how tall it is on what day? Day 15. So A is equal to 15. What does that equal? Our height on day 15. Really? You got what? You didn't get 92 and a half? Add the 25 to that, right? Add the 25. Oops. So it's total height. You have to include the initial amount as well because we want its total height on day 25. So yeah, on day 15. On day 15, we want its total height. Okay, so on day 15, his height is 92.5 centimeters. What other day do we need to know? 42. What is his finishing height? So 4.5 times our A value now is 42 plus 25. So what's our height on day 42? 240? 214 centimeters. They're both in centimeters. Okay, we're going to do a very rough sketch of our graph here. Very rough. Just makes you happy, I'm sure, because it'll be nice and quick. Yay. Now, who is the y variable here? Height, right? We had h equals. It's like y equals. So height is the y, the variable h. And then the x is days, which we expected that because time always goes as the independent. So days is a. Now, where's our first point located? Well, we're only looking between what two values, though? Between week 15 and week 42. So we're going to do a rough sketch. We have to look at day 15 and 42. And we need what two heights? 92 and a half and 214. So our plant growth, we're just looking between those two values. See what I mean by really like rough sketch? I'm just putting in the ones that are important. Beautiful. So beautiful. Now, what does it want us to do with this question? Domain and range in the context of this question. So the domain of this, instead of x, what's our variable for domain? A. So A is between what two values? 15 and 42. So is A greater than or less than 15? Greater than, equal to 15, and less than or equal to 42. Our range, what's our variable for range? H. And what are we between for our height? 92.5 and 214. And that's it. Okay, so the homework for this lesson is a couple questions in page 294 plus a worksheet. That's the homework. Let me talk to you about that for a second.